Hey guys, this is Subhranshu and welcome to my channel Tech Bytes. Here I come with a new series to talk about that is time-space complexity, sorting and searching. This subject is one of the most important part of any programming language and it's associated with data structure. We'll discuss all the concepts and for the coding part we'll use Java. So let's get started. From our day-to-day life problems perspective, there is not only one way to solve a problem. Different problems require different approaches, or you can say different problem should be addressed with different type of solution. In other words, not all the solutions are efficient and best suited. Similar way in algorithm context also there are different approaches to find the best solution, and that is where time and space complexities comes into the picture. The algorithm which takes less time, less space to process a task is considered to be the best solution. But in reality, achieving both best time and space complexity is not feasible. So it is always a trade-off between time and space complexities. When we are more concerned about the time of execution and not the space, we should use a time efficient algorithm. And when we are more concerned about the space during execution and not the execution time, we should use a space efficient algorithm. Having said that, when we need to have the most efficient algorithm with respect to time and space, it is important to select an appropriate algorithm judiciously, right? Another point I would like to stress about is we cannot compare one algorithm to another using exact values because they depend on the tools we use and underlying hardware. In fact, if we calculated time and space values of two instances running the same algorithm on the same system, there would be different values. That's because of the subtle changes in the system environment. Therefore, we use asymptotic analysis to compare time and space complexity of algorithms. So, by simple definition, space complexity is the amount of memory required for a program to process the task. And time complexity is the number of elementary operations an algorithm performs, right? And to summarize what we have discussed so far, there is not only one way to solve a problem. Second, algorithm which takes less time, less space is considered to be the best solution. Third, time and space complexity is a trade-off. Fourth, to measure time and space complexity, we usually do asymptotic analysis, right? So how we measure the time and space complexity? By three different types of notations: big omega, big O notation, big theta notation. For best case, big omega notation; for worst case, big O notation; and for average case, big theta notations. Right. So what is the best case? When we are doing a sorting operation, best case would be if the array is already in a sorted form. Right. And worst case would be if the array is already in ascending order and we want it to be in descending order, right? And average case would be somewhere in between best case and worst case, right? This table shows all the complexities of different sorting techniques, right? You see, these are all in log n, n square, like that in mathematical functions. So how does this mathematical function looks on a graph? Let's see that. You see here x3, x square, x. If you plot on a graph, this would be like this, where in x-axis that is number of elements and y-axis is the time. From this you can know log x is the most efficient one and x3 is the less efficient one. So this is all for time and space complexity. Thanks for watching guys. I'll see you at the next one.